Hello, and welcome to Data Engineering with Subhadeep. Today we are diving into a transformative topic, how large language models, or LLMs, are reshaping the world of data engineering. Let's explore this new frontier together. In this video, we will first discuss the fundamental shift in data engineering caused by LLMs. Then we will explore new core tasks like chunking embeddings and vector storage. After that, I will walk you through the architecture of a Retrieval-Augmented Generation, or RAG pipeline, and we will build one using Python and LangChain. Finally, we will wrap up with the key takeaways. Traditionally, data engineering has been about handling structured data. We build ETL or ELT pipelines to move data from databases and APIs into warehouses for business intelligence, but with LLMs, the focus is shifting dramatically. We now need to process vast amounts of unstructured data, like PDFs, text documents, and images, to make them understandable for AI models. This shift introduces new core responsibilities for data engineers. First is document chunking, where we break large texts into smaller pieces. Second, we build embedding pipelines to convert these text chunks into numerical vectors. Third, we manage vector storage using specialized databases for fast retrieval. And fourth, we implement prompt caching to optimize performance and cost. Let's look closer at chunking. LLMs can only process a certain amount of text at a time, which is called the context window. If your document is larger than this window, you have to split it. We use text splitters to create smaller chunks, often with some overlap between them. This overlap helps maintain context across the splits. Here is a simple Python example using LangChain to split a document into 1,000 character chunks with a 200 character overlap. Once we have our text chunks, we need to convert them into a format the machine can understand. This is where embeddings come in. An embedding is a list of numbers, a vector that represents the meaning of the text. We use pre-trained embedding models from providers like OpenAI or open source ones from Hugging Face to generate these vectors. The data engineering task is to build a reliable pipeline that takes text chunks and efficiently produces these embeddings. Now that we have these vectors, where do we store them? A normal SQL database is not efficient for this. We need a vector database. These databases are designed to perform lightning-fast similarity searches. When a user asks a question, we embed the question into a vector, and the database finds the stored text chunks with the most similar vectors. Popular options include ChromaDB, Pinecone, and Weaviate. Alright, let's put it all together in a demo. We will build a Retrieval-Augmented Generation, or RAG pipeline. The process starts by taking documents from a data source like a warehouse. We chunk them, create embeddings, and load them into a vector store. When a user asks a question, the system retrieves the most relevant chunks from the vector store and passes them to the LLM along with the original question. This gives the LLM the context it needs to generate an accurate answer based on your private data. Now for the code. First, we install the required libraries, including LangChain Open.ai for embeddings and ChromaDB for our vector store. We set our API key. Then we simulate loading data from a warehouse. For this demo, I have created a simple pandas data frame with some project reports. Finally, we convert each row of the data frame into a LangChain document object, which is the standard format the library works with. Next, we build the core of our pipeline. We initialize a text splitter, although for our very short documents it won't do much, but it is a crucial step for real-world data. We then initialize the OpenAI embedding model. The magic happens in the next step, where we create our Chroma vector store. We simply pass our documents and the embedding model to it. Behind the scenes, Chroma will embed each document and store it in an indexed local directory. Finally, we create a retriever object, which is what we will use to find relevant documents. Finally, let's ask a question. We define our query: why was Project Alpha a success? We then use LangChain to create a retrieval Q&A chain. This chain automatically takes our query, finds the relevant documents using our retriever, and then sends both the documents and the query to the OpenAI LLM. As you can see, the LLM correctly uses the provided context to answer that Project Alpha succeeded because it focused on agile methodologies. It did not just make something up, it used our data. So what are the key takeaways from all of this? First, data engineering is evolving beyond just structured data. We are now tasked with making unstructured data useful for AI. Second, this requires new tools and skills. Learning about vector databases and frameworks like LangChain is no longer optional. Third, building robust pipelines for unstructured data is the new frontier. And finally, the RAG pattern is a powerful technique you will see and use frequently to build reliable AI applications. That brings us to the end of this tutorial. Thank you for watching. I hope this gave you a clear overview of how data engineering is changing in the age of LLMs. If you found this video helpful, please hit the like button and subscribe to Data Engineering with Subhadip for more content like this. See you in the next one.